on my end. Um, so we're going to continue our discussion of the CRISP-DM methodology, right? And if you remember, I think when we met last time, I I was walking us through a Jupyter notebook associated with the so-called exploratory data analysis exercise that one would conduct typically as part of data understanding, but also as part of data preparation. But we, we decided to start going through, EDA, or understanding what EDA is all about as part of data understanding, because that is in fact the phase that we were going through. Yeah. So hopefully that was useful in trying to put certain things into perspective. And so what we're going to do today is we are going to transition into our discussion of phase number 3 of the CRISP-DM methodology. Now, a reminder again, or once more, that we are doing this because we're motivated for why it is important for us to use a standardized procedure or process when we are executing a data mining centric project. And the thinking is simple here. Typically, when you're working on a data mining project, you put together what's called a pipeline. And this pipeline comprises of various sets of activities. These are, in fact, the activities that we're discussing. As part of the CRISP DM approach, they manifest themselves in 6 distinct phases. So there's business understanding, data preparation, modeling, evaluation, and deployment. And so what we're doing is we are going through these phases one at a time. We initially started off by briefly explaining what typically happens in each and every one of these phases. And we are now going through them by looking at the different aspects of the so-called CRISP DM methodology. Right? So this notion that at a very high level, the CRISP DM approach or methodology comprises of quote-unquote phases. There are 6 of them. Each one of those different 6 phases is associated with so-called generic tasks. Each generic task is associated with specialized tasks, and the specialized tasks are each composed of so-called process instances. Right. And so in fact, what we're doing when we're going through these different phases is we are trying to explain all those different aspects as they relate to the 6 distinct phases. So, the interesting thing about data preparation here is that this is usually when you find yourself jumping into this, AI/data mining/machine learning/data science domain. Many a times you would start off by working on tutorials or examples which will have like a data set already prepared. Probably the data set is already labeled actually. And so in fact, what most people would do when they're jumping into this space for the first time is they'll typically just rotate in between modeling and data preparation really. So you come across these tutorials which will show you how to one hot encode data, categorical data, for instance, right? How to use word embeddings to convert text or content, for instance, into numeric representations, right? And so what we want to do today is we want to understand the broad spectrum of activities that are performed as part of data preparation. Turns out that there's quite a bit of work required. And really, in terms of the generic tasks, the things that one would do as part of data preparation is you obviously undergo what's called the data selection process. Right? So at this stage, you would have an idea as to which attributes you are going to include in whatever inference model that you're building as part of phase number 4, which is modeling. And this makes sense, right? Because one of the things that we noticed we can do with exploratory data analysis is we can sort of like identify correlations that exist amongst the different variables. So both independent variables and dependent variables, right? Using that information, we can really pinpoint which specific attributes we would want to incorporate during the model implementation phase, really, right? So there's data selection process, and then you have data preprocessing. There's quite a bit that goes on there. There's some tasks that are generic. They they'll be performed irrespective of the type of data attributes that you're dealing with. In some instances, there are certain operations that are specific to certain types of data attributes. Like I'll give you an example of remove of punctuations. I mean, there are no punctuations to remove when you're dealing with categorical data. However, when you find yourself working with text or content, depending on the problem that you're working on, you may find yourself wanting to remove stop words, for instance. So there's data pre-processing, and then there's data transformation, right, and derivation. So this notion that at this point or during this phase, what you want to do is you want to use appropriate techniques to convert the attributes that are characteristic of your data into a form that the estimators you're using or the algorithms you're using as part of modeling phase will be expecting. Typically, they'll say numbers, not all the time, but most of the time it's numbers. And then at this point, you also undergo what's called data derivation, right? So it turns out that there's certain attributes, for instance, year of birth, for instance, or date of birth, that in their raw form are not really going to be useful, right? So what you may want to do if you're doing your processing in 2025, for instance, is you may want to derive somebody's age using the date of birth. So you just subtract, the date of birth from 2025, which is this year, so that you derive the age. It turns out that there are usually a number of instances when you may want to derive attributes. A slew of examples where you are deriving attributes here. And I think our two data sets, I believe, do have attributes that will enable us better understand how this derivation process takes place. And then, of course, there's this notion of integration and merging of the disparate data sets that you may be working on. I showed you yesterday. I was trying to preempt the conversation we're having right now. I highlighted the fact that this student data set that we've been using as an example, the one that comprises of 69 attributes, in actual fact, was not what it is, right? It's a direct result of merging input data sets from 4 different sources, right? So at some point, we had to merge attributes from these 4 different sources so that we have one complete data set. And then, the other generic task you perform is you'd come up with a so-called data set description. In essence, just a comprehensive description of what sort of data set you're working towards. Now, as part of data selection, really, what we're saying you're doing is you are identifying quote unquote features or attributes or characteristics of the observations that comprise your data set. In actual fact, you're undergoing this process of identifying the features in order to select the attributes that you would want to include in the model implementation process, right? So identifying the features, really. And really, it turns out that the selection of the data is typically dependent on the problem space you're working on. In other words, the requirements. Anyway, more on this, I guess, when we look at specific examples of how we go about selecting these sort of data sets here. Right? Something else you do is, well, rather, another thing about this is what you're doing is you're choosing, as part of identifying features, you're choosing features that will provide meaningful insights for the model. It's like when you're dealing with our student data set. I gave an example of 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 I believe, is it academic year or something? That thing is not going to provide you with any meaningful insight, really, to be honest, right? I mean, sure, there are different values associated with academic performance, but for the most part, it turns out that incorporating that into the model implementation process is not going to be that useful. At some point, you may find yourself using, that data perhaps to just filter information somehow, but not really as part of a set of features that collectively will be used as input to build this model. You probably won't use that. In other words, what I'm saying is if we do an import pandas as PD and we do the usual student database is equal to pd.read CSV, right? And we do the usual stuff where we are using the separator and we're specifying that the separator for this is a pipe symbol, and we create a variable of type data frame, what we see here is a situation where, and you can tell this by looking at some of the results from your exploratory data analysis, right? Observe. I pull out. Let me start with the obvious one, right? I pull out student ID, right? And I see that all of these, hash representations of the student IDs, and I'm wondering, of what use is this going to be? Well, we already attempted to find out the unique set of stuff that we have in here, and if we count this, right, we see that we have 273 unique entries for student ID. Now, if you have unique entries for a particular column, really, of what use is it going to be in the model implementation process? The answer is no use at all, right? Again, if we look at the academic year, right, and we do something like, in fact, what I'm going to do is just maybe convert this into a list, right? Convert this into a list, and then also convert this again into a set, right? Because if you remember your Python, they tell us that one of the interesting characteristics about sets is they won't contain duplicate values, is it? But a list can contain duplicate values. So if I cast, the series into a list, I'll come up with a list, and then if I cast the list into a set, I'll come up with 4 unique entries. So in other words, the field academic year has a total of 4 unique entries. And if there are 4 of them, and I'm looking at them here, clearly they're not going to be of any use to me. And I can see here, right? They're not going to be of any use in any way here. These entries simply represent the 4 different cohort from where the data was collected. So I have data from the academic year 2027 slash 2020, 2017 slash 2017 slash 2028, 2017 slash 2018, 2018 slash 2019, 2019 slash 2020, and 2020 slash 2021, right? That's it. That's the only use this thing is going to have. And in some instances, when I'm conducting exploratory data analysis, perhaps faceting the data on this particular attribute may be of use, right? But when I get to model implementation process, it's not going to be useful in any way. Okay. So you're choosing the features that will provide meaningful insight into your model. And at this point as well, you want to ensure that you have a representative sample of data that will ultimately yield the required or the expected model performance. It turns out that the size of the data set that you are working with is extremely, extremely important. It influences the effectiveness. It's one of the reasons why I was showcasing to you people the map, right? I like using that as an example when I'm doing one of those crash course machine learning slash AI or classic classification problem, right? I'll showcase people, oh, if you go to scikit-learn and you just look up the map here, scikit-learn will give you an idea, or at least this map will give you an idea of how to make a decision on whether you can proceed with the model implementation process or not. This is what I'm talking about here. By the way, this one time, 2019, I think it was just before the pandemic hit, I was attending a workshop somewhere. I was in Cape Town, I think it was. Yes, it was in Cape Town, as part of the CGIR/KDD AFEM workshop, series of workshops. And there's this person from Italy who was giving one of the workshop presentations, and he kept on referring to scikit-learn. And I'm sitting there and I'm thinking, what is scikit-learn? It turns out the pronunciation, he was trying to pronounce scikit-learn, right? To him, it was scikit-learn. But anyway, so you want to ensure that you pick the appropriate model size. So that's that about generic task tagged as data selection process. Something else that you do is you do a whole lot of data pre-processing. Now, when you're pre-processing data, what you're essentially doing is quote unquote cleaning the data. Usually, most of the time actually, if not all the time, but usually the data that you find yourself harvesting from a source is going to be messy, right? So it needs to be cleaned. Again, the data set that I provided to you is already pre-processed. It's cleaned, right? Which is why it's relatively easier for you to work with that data. But usually you will come across data that has a lot of errors. Like somebody tells you these are student grades, and you find grades that are -5 or -10, you know, and maybe you say, oh, maybe this lecturer gives negative scores like Lighton does, right? For people that don't want to do the assignment, uh, which by the way I'll be updating hopefully by tomorrow. So if you are excited about losing marks, don't worry, we'll do that for you. But also, right? There are instances where the negative could be valid, the negative score could be valid. However, the you know having a grade of 120% is not normal, right? Because you know that a percentage can only go up to 100%. You understand? So the idea behind preprocessing is you're trying to identify all these anomalies. In fact, you'd have identified the anomalies at some point, but you're coming up with workarounds on how to fix those anomalies. So the things that you do is you go about identifying or handling issues to do with missing values. So if you have entries with missing values, what do you do? Right? It's like if we go to our data set, our student data set, we know for a fact that there are certain entries for the final exam. Final exam is an extremely important examination. It's an extremely important attribute, right? It's like one of the dependent variables, DV, independent dependent variables. Remember your statistics, but it turns out that we have entries where the values are now, right? And in fact, we can, if you've done your homework, you could say, is it Isene or something, right? You could do a Isene to check out of these entries for exam score. Kind of like how many are now? Is it Isene? I don't know if I can do a group. I don't know if I can do a group by here. Can I do a size right here and then? No, I can't. But you have an Isene, and then you could say, well, I want to figure out I want to see the records that have um, now NA equal to true. Is NA is not a number. So in other words, what I'm saying is that I'm checking for records where the entry is NA. NA is now. Okay. So I have clearly here, if I use this as a condition, I see that out of the 273 observations, 26 of them do not have entries for the final exam. We don't know why. Maybe the students decided to withdraw. They decided to forfeit the course. It was too hard. They just couldn't keep up. I don't know. But anyway, for now, we're checking here. Oh, these are the entries with now values. And so once you identify the now values, it's like, what are you going to do with these now values? Right? There's a series of things that you can do. You can perhaps replace them, right? Um, you can replace them with default values, for instance. If these are exam scores, you could say, what I'm going to do is I'm going to replace all exam scores with now values with a 0. If you have no exam entry, it's as good as getting a 0 or something. You ran away from the exam or something like that. I don't know, right? In some instances, in some use cases, you may decide to um, let's say, I'm going to replace them with maybe the minimum value or something. Sorry, the mean value, the average. Imagine you are working with a data set where you have average spend for students, right, at UNZA. I don't know what sort of application you'd be building which is using like the amount of money on average that uh, uh, amount of money that students spend per month or something. You'd say, instead of if you have now entries, you say, I'm going to replace the now entries with just the average values. It may not be true, but it may not be true, but it's better than not doing anything at all. I guess is the argument you'd be making in that particular instance. Anyways, so in this particular case, by the way, one of the things that you can do, I don't know how much of pandas you've read, but this, observe, if we get which is this is okay. I'm just going to say this dot is yeah. So you have a few in there, for instance. You could say for, well, I don't know about this here, but maybe I want to replace a specific field or something. So what I could do is, because what this does is it shows you it shows you how to replace all now entries in a data frame. So in this particular case, I would say what I want to do is, if I say few NA, I want to replace everything with I'm feeding it a value, right? With just an empty quote or something. And you notice here, if I say I'm replacing all now entries with an empty string, all of a sudden, the stuff that previously had NA, like NA is like a default representation of a now ent, right? Not a number. They are suddenly empty strings. By the way, this this thing, right? There's something really interesting about how pandas works. In most instances, it will not persist. I don't think it persists, right? If you do this. So if I check the data frame here, it's still going to have any values, any entries like that. So in other words, what comes out of this, what comes out of this is like a copy, more or less like a shallow copy of your data frame or something like that. If that makes sense, right? In other words, look at this. This is the data frame. Before, I still have NA values. If I say dot fill NA, and I say, instead of empty string, actually I'm going to fill NA with a 0, it's showing me that everything where there's now entries, I'm replacing them with a 0, right? But the data frame, the original data frame, is still going to remain the same. It turns out that when you want these changes to persist, you'd have to you'd have to use the in place flag, right? So in place, I think in place is equal to true, something like this. Is it in place? I don't know if it's one word. Yeah. So lowercase p, in place is equal to true. So now if I check the original data frame, I'm going to have zeros all over here. So I'm going to roll back to what it was before, and I'll have to do this, reinitialize the variable that's holding the data frame, right, in memory or something. Anyway, that's okay. By the way this thing works, right? I don't know if you've bothered to read up on how pandas works. Is everything is in memory, is it? Everything is being swallowed in memory here. It's the reason why when you're working with a large data set, you run into memory errors. Observe, I have, I guess, I don't know if H is going to be the way to know. I'll use M for megabytes, much better. So it's like if I start watching this like this in real time, my free memory right now is hovering around, this is what? About 5,530 or so. Let's say 5,500 megabytes of free memory, right? If I, and I know it's not a very large data set here, but hopefully it's going to showcase the example. 5,500. If I come here and I say, I'm going to swallow this whole chunk of stuff here, but this may not really showcase what I want to showcase, but let's see. Import pandas as PD, and then I'm going to say var student database is equal to pd.read, right? CSV. Don't know if this will, I hope this works here. I'm trying to showcase to you, those of you, there we go. You see, it was somewhere 5,530, somewhere there. Like it's almost the entire data set is in memory. It's a small data set anyway, so you wouldn't really appreciate this. But what if we said var unser dspace? Here, actually, we do this, and we say var unser dspace. We swallow this into memory as well, the dspace data set. It's slightly larger, but then also it's not a very large data set. I wish I had a very large data set. I just wanted to showcase to you. So the way this thing works is everything is in memory, in other words, right? You see that? This is why my memory, the free memory that I is being reported here is shrinking, is it? Anyway, That's neither here nor there. So we have the in place flag that you can use. And true to that, right? If you're paying attention where we had the .info, we realized that, come on now, we realized that there were a couple of other fields, ladies and gentlemen, that had now entries. Of course, the representation here, these are non-now entries, but we see that entries like which ones are the hardest hit here? Entries like survey results. Survey results. Look at this. The survey major motivation, right? Survey major motivation, like so. We see that the number of entries where they are now, right? Now. And so if you wanted to do something meaningful with the field survey major motivation, what you'd have to do first is you'd have to maybe either drop, by the way, you can drop NA or you can say field NA, depending on your decision. So in this particular case, I'm going to say I want to, the length of this series is what, 273, right? I want to replace all the now entries with an a string called missing data. I use this a lot, right? You notice your results. You see what okay, it's okay. What I do is I use missing data. It's a lot easier for me to work with information when I put an explicit tag. It's like a token that tells me that there's missing information. Then what I do when I'm doing a few NAs, I'm saying for this particular series, for all entries which are now, replace them with missing data or something. That's a decision you're making, right? When, ladies and gentlemen, when a decision you're making when you're handling these missing values. Something else you can do is you can drop NA. I think there should be a drop NA. Yes, there is. If you say data frame dot drop NA, right? You see that? Drop NA is there, right? So you can do a drop NA. And in fact, what you do is you can say drop NA. It will show you, I think you can feed it flags like first, keep, and stuff. Keep is equal to first, last, and all those things. So if you do I think it's a help or something, or dir help, I think it is. The keep, I don't know where keep is here. I'm looking for keep, but you can feed it. Why can't I find keep? Drop NA, how access? There should be a keep, I believe. Where you specify, unless if I'm thinking of something else here. How, or I don't know. Maybe I'm thinking of something else here. But anyway, so you can drop, like in this particular case, right? Observe the number of entries I have for this is 273. What I can say is I can say I want to drop NA, right? So in other words, drop all the entries that are now. And in fact, I think when I drop them, it returns the data frame and they can count. I have 111 when I drop the NAs. In other words, I'm making a decision on what exactly I want done to things that have missing values. You can replace them with defaults, or you can get rid of them, exclude them from your analysis. I always like creating a shallow copy myself rather than dropping. You'll notice that as you progress in your pipeline, you need to revert to previous versions of your data frame or a previous point in your pipeline, your notebook or something. So for me, I mean, it's all easier that way. So you're handling as part of preprocessing, you're handling missing values, you're handling duplicates, you're applying general preprocessing actions. Imagine our data set, right? This. We know that we have records for students, right? Well, if we're working with records of students, we wouldn't want to have duplicate entries, right? It's a record per student. So what we may decide to do is we may decide to delete duplicates, for instance. Come up with a decision on how you're going to handle the duplicates. Yeah, how to handle the duplicates. So you can delete them. Well, usually it's deleting anyway. You don't want to keep duplicates. I mean, I'm trying to think if there's a unique, I don't know, maybe you guys can think of a unique case in which you'd want to work with duplicates. Hello? Are you even following? I don't know if I'm talking to myself here. Can you hear me, by the way? Don't know what's happening here. Oh yeah.
Yes, we can follow you.
Okay. Right. So you can also I mean, this notion of handling duplicates, right? There are instances where, let me see here. Okay, I'm gonna showcase an example here. I mean, let's say this wouldn't really happen, but let's let's just say you guys or you are working with the data set and you want to work with I don't know here. Okay, let's say you're working with minors, right? Minor descriptions. Where are they? Student minor descriptions, survey minor is what I'm looking for. Maybe I don't know if nationality, but minor is better actually. So minor description, right? This is what I have here. Now the thing about this, right? These are 273, you know. But if I do a unique, or in fact, if I just convert this into a set and count it, if you remember Python, I see that there are 10. They're actually, in as much as there are 273 entries, but 10 of there are 10 unique entries, if that makes sense. Now, if there are 10 unique entries, and for some weird reason, I just wanted to, I didn't want to work with duplicates. The idea behind handling these duplicates is you've got to make a decision on what you're going to do with duplicate entries. So Python pandas has something like I think there's a dot duplicates. Let me just check. Dot duplicates, duplicated, not duplicates. But it should be a dot duplicates, duplicated just returns true or something. But there's a drop duplicate. Yeah, drop duplicates, right? So you can choose to say, I want to get rid of the duplicates for this entry, right? For this particular series, minor description. Now, the thing is, if you think about it, right? If you look at this, let's say I wanted not to have duplicate specific education. Um, the question is, which ones do I drop? Do I drop the first one? Do I drop, the last one or something? If that makes sense. And so if you read up on drop duplicates, right? You want to your help inbuilt is your friend. Um, I think drop duplicates should have a keep here, right? Keep. So are you going to keep the first record? Are you going to keep the last record? Hmm? The default is you're keeping the first record. So in other words, if I ran, I don't know about this here, but if I ran this dot drop duplicates, right? Just the way it is here. What this thing is going to do is it's going to return, and you notice here it's actually skipped numbers here, right? Index 0, 1. So I've kept the first one, is it? This one here. These other ones, the one that was at 268, it's gone now. Bye bye, right? Um, if this making sense, I don't know. Or you can tell. By the way, again, this you have to, if you want to modify the current data frame, you've got to use the in place is equal to true flag, right? So if I check this again, it will still return the 273 records, observations or something. But I can also say keep is equal to last. So I want to keep the last record or something. So if I'm keeping the last records, you notice now the things that I'm keeping here are at the tail end, right? The tail end of the series and not at the very first. When I ran duplicates with the default option, which keeps first, this is what I have, right? These indices here are the ones that are at the beginning or something. Anyway, if I want to look at this, what I'm trying to say here is that as part of preprocessing, you identify missing values, or you come up with workarounds for how you're going to handle missing values, workarounds from how you're going to handle duplicate entries. Now, here's the thing: irrespective of whether you're working with sound, audio, images, video and stuff, in almost all these instances, all these different data attributes, you're going to have to figure out how to handle missing values and duplicates. However, when you're working with text, there are additional preprocessing actions that you tend to perform. I'll talk about them just now. So, for instance, removing kind of like stop words and punctuations, and applying stemming, right? Lemmatization, and all the fancy things to do with text. Not that you'd apply these things to your text all the time. It's contextual, depends on the problem that you're working on. But anyway, so fundamentally, right, if you're following through here, this is a phase, generic tasks, specialized tasks with associated process instances. So again, when you're handling missing values here, we see here that you can make a decision to impute missing values. I am going to replace student scores. Those of you that are not going to attempt the lab, in class lab next week on Thursday, what I'll do in my results is, instead of adding NA, I will replace all of those entries with 0. That's a classic example of how a scenario of where I would want to impute, right? You are replacing missing values or null values with some value. In this particular case, it says 0. And really, in the problem space I'll be working on, that makes sense, right? In some instances, let's say I gave an example of how much people get paid, and you have null values, and you don't have the luxury of excluding entries with missing values. I want to replace them with the average or something like that. Anyway, there could be other ways of addressing missing values. When I'm working with text myself, I'm going to show you this here. When I'm working with text, this is what I do for missing values. I don't know if you've seen this, you guys. Missing values here. But no, not this one. What I would do is I would, you see this? Instead of leaving it empty here, this is what I tend to do when I'm working with text. I'll just put a token, right? A token that will remind me that this entry does not have data for this value. So I'll just say data missing or something like that. By the way, data missing is for the first name or last name, I guess, I don't know. Data missing is for the first name or last name or something like that. That's why we have two data missing here. In an ideal case, you have first name, last name, right? So if no first name exists, I put data missing. It's just a way of, marking that token is missing or something like that. I don't know. Anyway, so there is this, or removing, right? Removing is the easiest. In fact, if you have the luxury of excluding, please exclude. Whenever you're working with a data set and you won't really be faced with a situation where you have insufficient data, if you remove entries with missing values, by all means, remove the missing values. We cannot do that for our data set. Observe, we have 273 entries. If I say drop NA, how many entries do I have left? Empty data frame. Wow. This is meaning that this thing, because when I'm saying drop NA, I'm saying for each of these different observations or records, whenever you find a column with a missing value, drop it. Horrible idea, right? Horrible idea. Why? Well, I mean, virtually each and every, I don't know if this will work here, but virtually each and every, I'll do an ilog, each and every, for the first one, record, in this particular case, has some now entry, right? You know why? Because even if you're a very good student, this data frame, this data set is created in such a way that I have makeup tests, and makeup tests typically for courses that I administer or where I'm course instructor, I only administer to students who are sick or have a bereavement, some serious issue here, right? Not when you're out partying or something like that. And so the thing here is that there are some good students who will have a now entry for makeup tests because they wrote test 1 and test 2, right? So in whatever scenario you can ever think of, there will always be records which will have now entries. Hence, if I do a drop NA, boom, it's gone like that. I don't know if this is making maybe it is making sense or something. Yeah, I don't know. Anyway, so you handle missing data entries, you clean up duplicate records to ensure unique data points. Again, this is contextual. You would also standardize numeric data to ensure all features are on the same scale. So for instance, one of the things that you would do is you want to say, I want to scale. Oh, this is a bad example though. Final examination. You see, the data sets that I have for the results, the data sets that I have for the results is tricky here. I don't know how. Also, I remember this data set when I touched it a long time ago. But they have quizzes, there are tests, there's a final exam. 20 quizzes, 4 tests, and 1 final exam. Now, the thing here is that the quizzes use a scale of 0 to 10. They're always out of 10 in this course. The tests, because they're written in 1 hour, are always out of 50. The exam, however, is always at 100. So if, let's say, I'm doing some sort of processing, right? Some sort of analysis. In as much as these are numeric entries here, what I may want to do is scale these values. Why? Because I want to use a common scale, percentage typically. So I'll multiply this by 10, this by 2, and this by 1, or not do anything to this. I am scaling. And the thing about scaling is it will make sense when we start. I don't know if it's part of the syllabus, but when we look at, let's say, unsupervised machine learning, right? What you notice is that for you to come up with patterns that are sort of like meaningful, I don't know if we do that, you'd want to scale the numeric values in such a way that they're from 0 to 1. It's a lot easier that way for you to, like if you're using k-means clustering, it's a lot easier for you to come up with a nice visualization of your clusters, right, associated with your data set or something. So you use standard numeric scales, for instance. But also, there are these specialized preprocessing operations I was talking about. For instance, when you're handling text, the different preprocessing tasks that you perform when you're handling images, for instance, right? So duplicates and unique entries. Now, for text, right? And we have a dedicated lecture session immediately after this, I think, when we look at a classic preprocessing, detailed examples, I think it is. But in essence, what we are saying is when you're handling text, if you look at our data set, right? And one of the fields where we have text, we know, is the motivation. Why the hell did you decide to do this course, right? We ask them this, and then they have, look at this. These are the people we ask, right? They'll tell us, well, I decided to do this course, apparently, because to comprehend how the computing environment, I don't know what this is here, but there's a whole range of, do head 100. There's a whole range of, 100 is tail, maybe tail 5 or something. There's a whole range of reasons, right? Learn about computers. Maybe we can even do the dot, drop NA. Why not, right? Drop NA in place. Beautiful stuff. No in place here. Drop NA. So these are the different reasons, but this is text. Forget about why people would enroll in this course, right? Because of the changing world, apparently the demand of ICT skills is growing. Well, this was before the rise of the machines here. But the thing here is the idea behind preprocessing, and what I'm going to do is I'm going to say student database major motivation. I'm going to create a completely different thing here, like this, so that it's not easy to work with, right? Just 111 entries. It's a completely new data frame here, right? It's data frame with just one unique entry here. It doesn't matter. It's a series, actually. So the thing about this is we are saying there's a range of processing tasks we can perform. For instance, when you're working with text, one of the very first things you do is you ensure that the casing is consistent. It must be consistent. So in other words, what you do is you come to your data frame, like, ladies and gentlemen, I'm going to have to here's what I'm going to do here. I'm going to say this. I don't want to pollute database. I don't want to pollute the original thing. I'll just create a separate field here to say, uh, yeah, it's okay like this, I guess, just the way it is. I'll use, I don't want to confuse people here. I'll use an entry that I know has a value, right? But one of the things, ladies and gentlemen, one of the things that you're doing is you want to work with a consistent casing. Now, if you look at the mess here, usually when you're dealing with data where users have the opportunity to specify open-ended text, it becomes, it's a wild, wild west, as the white man calls it, right? Everybody does what they want here. If you notice here, some people, I don't know why you'd want to write in all uppercase, right? It's like you press caps lock and you're typing, right? My aim is to become a programmer. You're shouting, but that's fine. Some people use title casing. Some people use sentence casing. Some people use lowercase casing. And so the idea is, one of the very first things that you do is you normalize the casing. And usually what I do myself is I use all lowercase. So what I'll do is I'll say I want to convert every piece of text, like for this particular series, it has got to be, it has got to use a consistent casing. So I would say, usually what I'll do is I'll define a function, say to lower or something like that. And in here I'll say get a string. I'll just say call it input, and then I'll say really df. Come on. And then I'll say return var input dot lower, like this. So that what I'll then do is I would if you remember, I did this right before, once before. I would get the, oh, come on, I would get the column that I'm interested in, which is this, and then I would say, what do I want to do? I want to apply, if you remember the apply function. What do I want to apply? The function that I just created, the to lower, right? The reason why this is happening, by the way, is that this is horrible stuff. Because some entries have now values, you tend to run into this error. So one of the very first things you should probably do is, for this to make sense, I'll just say fill na. I'll just replace it with this, and then in place is equal to true, like this. And then what I'm then going to do here is apply my function. So now it works, right? Now I've created a function that is normalized somehow. So I can say var student database and say this is equal to, I want to call this, I like maintaining these things, right? I'm going to maintain this like this, and I'll say lower, so that when I check my data frame like this for the columns, I'll have this lower series that I've just created. And if I check this series that I've just created, I will have this, right? So these are all lowercase variations. And in fact, if I start running the drop na, the stuff that I was doing here, you notice that drop na, I don't know, but there's no na now because I replaced all nas with, it's crazy. I replaced all nas with spaces, is it? So if I check the tail, you notice that all of them are using a consistent casing, all lowercase, all lowercase. I am pre-processing. What else do I do? Well, I can remove punctuations. You see, if you look at the original data that is here, that these guys were working on this, what you begin to notice is that some text, and this is a horrible example, but some text will have punctuations. Like, look at this. I am currently in my 4th year. I do hope I pass. In fact, I shall pray, or something like that. Now, here's the thing. When you look at this, right? If you look at this piece of text here, for you and me, the structure of the sentence is important. The full stops are important. They have meaning. The full colon has meaning, right? However, what you soon discover is that the machine doesn't care whether there's a comma or a full stop, right? And this will make sense when I showcase examples here. And so what we do when we're building models that take in text as input, again, this is context, but most of the time is we remove punctuations. They are useless. And one of the reasons we remove punctuations is because there's something interesting when you're working with text, right? One of the things that typically when you're working with text, you come up with a vector that has a representation of possible combinations. Like for an observation, let's say it's student ID, right? And then I have motivation, text one, text or something, text one, text two, text. And then you have student ID 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you have like text two, text. The thing is, what you do when you're working with text like this as part of the transformation process is you vectorize this. And the way you vectorize this is, it's interesting. The simplest way of vectorizing this, we'll talk about this actually during transformation very, very soon, in detail in the next lecture series. But what you do is you create a vector of words. And the vector of words typically would have to correspond to your corpus. So it's like for all of these different entries for motivation, we are creating a corpus of these unique words for each of these documents, right? This is a document. This is a document here. So it's like you're going to have arranged, right, in a vector. I am, what is Zambia, me. Now, depending on the corpus you're working on, imagine you're working on the DSpace repository. Those abstract texts here have so many different word combinations. And this is so large, right? Now, because this is large, if you keep your punctuations, the punctuations are going to be considered as being separate tokens, if you will. So to reduce the size of the vector, because you're using more compute resources if your vector is large, right? This is the reason why we are going to look at dimensionality reduction. I think there is in your syllabus or something like that. To do this, one of the things you do is you remove punctuations, but also punctuations will typically not have meaning for most problem cases. Some instances they may, right? What else do we do? Here's the thing about the language that we use the most in this part of the world: English. In English, in the English language, there are so-called common words, right? Common words like I, am, me. These are common words. They appear often in whatever piece of text you're working with. You will find them there, right? The technical term referred to these things is stop words. So the idea is, as part of preprocessing, one of the other things that you do is you have got to remove, you typically would remove your stop words, if that makes sense. And again, the reason you're removing these stop words is so that you don't have to worry about the gory details of what my vector is so large, right? These things, by the way, can be so large. I don't know if I have an example, but I'll showcase an example, I think, when we have thing. But what you do typically is I'll showcase exactly one of the most popular natural language processing libraries or something is NLTK, right? So you do something like import NLTK. I hope I've already downloaded import NLTK. This thing says I don't have NLTK installed. So I would have to do something like pip. This is crazy. Pip install NLTK. Install. I don't know what's happening here. Install NLTK. So I don't know what's happening here. Maybe pip 3 or something. I'd have to probably log in into a different. I have so many different. I may be installing this different or something. But and I'm looking at the time here. But the idea is you are, let me see here. Yes, is there input here from I'm gonna, you know what I'm gonna do here? I've messed up my installation big time actually. On my computer, I have so many different environments here. So uh, NLTK or something like that. I know Jupyter Lab already has this installed here. This NLTK is one of the most popular libraries, so it's there on Google Colab by default. So what I would do is I would I don't know what's happening here. I would install NLTK, right? Natural Language Toolkit library, and then once I do this, I can do fancy things like I can say I want to import from NLT NLT Natural Language Toolkit dot corpus import stop words like so. And then what I'll then do is I would say stop words. If I just ran stop words dot words, I wish I could showcase this. I can then specify to say I'm interested in all the stop words in English, right? So what this thing is doing, and I'll have to download this first actually. So I'll have to run this first. If you notice, it's telling me there's an error quite right, a lookup error, but I'll have to come up on top here as part of the import statement. I have to download the stop words because stop words are linked to the language, is it? There's stop words for English and French and stuff. Good luck finding stop words for Bemba here, you know, Chicheo or something. It's crazy. These languages are low resource languages, right? But so if I do this and I run this, what NLTK does is it shows me to say these are the common stop words. So in other words, one of the things that you do as part of processing is you say, I want to exclude all of these common words. Now again, this is contextual. There's some problems, right? Where you may not need to remove stop words. But for most common use cases, you tend, and in fact, if you're going to be vectorizing things, you tend to remove stop words, right? So you remove there, there's there, then there, these, they'll, there's so many different words, and you can actually do a count also here to count how many stop words are in the English language according to NLTK. Well, you are removing 198 words. But guess what? Imagine you're working in a domain like physics or computer science. If you're working in a domain like computer science, the word computer or hard drive is going to be a stop word, right? So one of the things that you do, depending on the problem you're addressing, is you're going to have to expand on the stop words. If this is making sense, I don't know. I always not joke with, but I always, when I'm interacting with students, usually it's like there's a master's student, there's the data mining course at master's level. I always tell them, if you look up online, you notice a translation. I mean, it's gotten better, but translation from Chichewa, Silozi to English or Ishtonga to English is terrible. Why? Most of the language in our country, these languages, they are low resource languages, right? They're not supported online. Why? People like you who are trained to come up with solutions will rarely bother about these problems. You'd much rather work in the fin sector, right? The fintech sector, because that's where the money is and all that. I don't know. Hey, listen, there's this. I saw this the other time. I don't know how many of you guys saw this. I'm gonna leave you with this. We're gonna continue this conversation tomorrow. But there's this company called this entity, this enterprise called is it Bongo Hive or something? I think Bongo Hive. There's this languages thing that I'll be talking about. I would like to encourage you. It's unfortunate none of you guys are going to be working on anything to do with languages in your toy projects, but they're working on this. I just remembered when we talk about languages here. Please attend. I think it's free also. Where is that thing? They were advertising it recently. Language. I don't know. They were advertised this. You see this? There's this thing on the 28th. Apparently, it's I don't know. I mean, I said I'm going to attend this thing myself. I feel very strongly about languages, right? I always tell people I have very good friends that have spent years studying languages, right? Zola Mahaza, Dr. Balatha, a very good friend of mine, does crazy things with anthologies, right? and he's obsessed with languages because he comes from a part of the world, South Africa, where if you go to an ATM machine, you'll find an ATM machine in isiXhosa, in Zulu, in isiZulu, in Afrikaans, in English, so it makes sense for them. But in this part of the world, right? I don't know. I sit here and I'm thinking, in what use case, if I think about myself, what use case would I find myself making use of like solutions that look at languages? Well, maybe when we are sending targeted messages to remote areas, okay. But conversations in parliament are in English, right? Official communication is in English. I don't know. But you probably want to attend this. I do encourage you. It's on the 28th. It's a virtual event. I think at that stage would have done quite a bit in the course itself. But the key thing I want to leave you with, and we're going to continue about this because there are other processing tasks like stemming and lemmatization. Maybe we can just finalize them, right? So stop word removal. But something else that you do is you can stem, right? Because remember, I'm saying that you're creating a vector of words, so that you find the numeric representation of the numeric meaning of the word itself. So simplest case, you would say, does the word I appear in this document? If it does, you give it a score of 1. Like how many? It's 1. Does it appear here? No, it's a 0. Does it I am appear here? No. How about here 1 time? Does Zambia appear here? 1. Here 1. Does me appear here? 1. Here 0. Right? Now, if you think about it, right, this thing would be so dense, right? The goal is to make sure this is passed. Now it gets even better, because when you're translating this into numbers, it turns out that you don't want to distort the meaning. Here's the thing: I am from the Republic of Zambia. If you're going to use what are called unigrams, right? So you're creating a vector where you're just looking at representing single words. This is going to be problematic, right? Because you won't capture the meaning of Republic of Zambia. And so what you tend to do is you experimentally would figure out that, oh, if I use bigrams or trigrams, it's going to be a lot better, right? So that here you have something like Republic of Zambia. If you can mute your microphone, that would be nice here. Now, the moment you're using unigrams and trigrams here, it's like you're no longer just looking at these things as individuals. If it's trigrams, you're going to look at I am from the Republic of and Zambia individually, and then you consider I am separately, am from the Republic of Zambia, right? And then trigrams as well. And so this thing is going to be so large. Hence the reason why we are saying we have got to remove stop words. But something else we have got to do is we have got to stem, right? So the idea behind stemming is you're reducing words to their root form. So this notion that something like Zambia, from the perspective of a computer, Zambian and Zambians will pretty much have the same meaning. If they have the same meaning, then we don't have to have separate entries for Zambia, Zambians, and Zambians. It's like runs, runs, running, right? They have the same meaning, more or less. I mean, depending on how the context you're using them in, they could be different. But fundamentally, they could have the same meaning. If they have the same meaning, then what you want to do is you say, I want to reduce them to a root form so that I reduce the size of the vector. So instead of having something like Zambia and Zambian and Zambians, what you're going to have is you're just going to have to capture one word to represent all of these. So you stem, right? And stemming is quite simple, really. Again, I want us to jump to the next thing, next class. But stemming is quite simple, really. What you do is you would obviously import, again, NLTK is probably one of the most widely used techniques here. It's just say stem. Oh, look at this. There's AI here, right? Import porter stemmer, right? This is one of the things. You import your desired stemming algorithm, if you will, or stemming technique. Porter stemmer is probably one of the most widely used stemming algorithms, but there are a number of them, right? Observe this dot. These are the different stemming algorithms. Well, some of them are for lemmatization here, but Lancaster stemmer, right? A whole bunch of them. What else is there? Porter stemma, snowball stemma. Some of them I haven't used, but I almost always use Porter stemma, right? So I do this, and I would say, well, afterwards I'll create an instance, right? An instance of let's say it's a Porter var stem is equal to Porter. Why can't I just? Oh, there we go. It's here. I'm going to create this, and then I'm going to say I'm then going to. But this is var though, and then I'm going to say I'll create. Oh, here's the thing: var stem dot stem. Oh, it knows running, right? If I say run, look at this. Run. If I stem run, I get run, right? If I stem runs, I get run. If I stem running, I get run. If this is making sense. So you notice here that the goal here is to reduce the size of the vector. These are like just techniques, and I guess when people are coming up with these things, it was at a time when compute resources were insanely scarce. These days, we run on computers with 32 GB of RAM. 32 GB of RAM, for instance. If this is making sense, I don't know. And somebody is trying to call me because there's a class here, right? Sometimes we can't continue pushing important things like teaching here prioritizing other things at the detriment of teaching. And then there's lemmatization. But if you read up on how stemming works, for instance, what you begin to notice is that, by the way, I have to just say in class, we'll call back so that it doesn't appear like this reb or something like that, right? I don't know. So but you also have lemmatization. Again, stemming and lemmatization are more or less the same, but it's how you're playing around with these words, right? With stemming, what you're doing is, I don't know if you see this, but if you read up on this, you're just removing the suffix. It's the heuristic works in a very trivial manner. It's a brute force kind of approach. But lemmatization is slightly different, right? Because what you're doing is you're applying specific vocabulary and grammar rules, right? And in fact, you can do this experimentally, but usually what people do is they'll prefer lemmatization over stemming. But again, it's contextual, so it depends on the problem, And so a whole bunch of things that you are doing. And on that note, I just wanted to mention that these are some of the example pre-processing activities that you perform, because I think we're supposed to have, I don't know how detailed it's going to be, but you may just have to convert this into a Jupyter notebook, and then I'll walk you through a Jupyter notebook. But this is what you do as part of pre-processing. I'm going to pause here and ask if there are questions when we have class on Saturday at 18 hours, because tomorrow, I'm attending this other event also, and then also I have a class at 18 hours, so I can't have class with you at 18 hours. But when we meet next Saturday, we're going to look at what we do as part of transformation. And again, a reminder that what we're doing for each phase, we're on data preparation. The phase data preparation is associated with what? With generic tasks. Data selection process, data preprocessing, which is what we're looking at. Each of these generic tasks has specialized tasks. Data preprocessing has, handling of null values and missing values and deduplication, application of general preprocessing tasks as they relate to text or content, for instance, and stuff, right? Then you have specific instances, process instances. I don't know if this is making sense, but already, because almost all of you are, surprise, surprise, working with text data. I don't know if you figured this out. What I'm going to do is I'm going to insist that we have a dedicated session pre-processing where we focus on text to help you work on your respective toy projects. All of you are working on text data for a reason. I'm going to pause here and ask if there are questions, but I see here, what's cutting? Are we having class or not? Yeah, but we are. This was at 17:59. Wow. Mr. Sekeseke here is quite the diligent student. He was in class before 18. merging, toy. Uh, are you going to provide a walkthrough? Yes, I'll provide a Google Colab. I'll create a Google Colab for data preprocessing. Yes. Colab. Colab is 1L. Okay, if there are no questions, thank you very much, everybody. I will try and I thought I was recording this, but it appears I wasn't recording, which is unfortunate. I always have a backup. I hope I was recording using OBS, so I will share this recording. Thanks. See you on Saturday. Bye.
Absolutely you.
Hi. Yes, for somebody. I was just having class. I'm about to join. I'll be joining. So thanks.
All right. Okay. Please, we are waiting for you.
Yeah.